Reluctance. We have seen what magnetomotive force or MMF is and what magnetic flux is. MMF is the cause of magnetic flux through any material. Flux can pass through both magnetic materials like iron as well as non-magnetic materials like air or paper. The difference between these materials is how easily the flux passes through them. Magnetic materials very easily permit flux through them. So, even with a small MMF, we can get more magnetic flux. But in non-magnetic materials, the magnetic flux through them will pass through much difficulty. That means we need to supply more MMF to get the same amount of magnetic flux as in the case of a magnetic material. We can say that some materials are more reluctant to the flow of magnetic flux through them than others. So, we define a new term called reluctance to represent this behavior of materials. Reluctance of a material is the ease with which it will allow magnetic flux to pass through it. We can now write the relation between MMF and flux as phi is proportional to F, where phi is the flux through the material and F is the MMF acting on it. Since reluctance determines how much flux is created due to MMF, we can write phi is equal to F by R, where R is the reluctance of the material. Reluctance is represented by the cursive letter R, while resistance is represented by the normal letter R. We can rearrange the equation as F is equal to phi into R or MMF is equal to flux into reluctance. This equation is similar to Ohm's law, that is EMF is equal to current into resistance. Reluctance of a material depends on various factors. They are the type of the material as well as the dimensions of the specimen. A specimen with higher permeability will have a lower reluctance. Higher permeability means more flux can pass through the material. This means lower reluctance. The reluctance of a specimen will increase with the length of the specimen. This is like driving through a crowded road. If we have traveled more distance on that road, we will take more time to cover the same distance compared to an empty road. Reluctance is inversely proportional to the cross section of the specimen. That is, a specimen with large cross-sectional area will have a lower reluctance. If there are more lanes in a highway, more vehicles can travel through it without crowding. Likewise, larger cross-sectional area allows more flux to pass through it. Combining these, we can write an expression for reluctance as R is equal to L divided by mu into A, where L is the length of the specimen, A is its cross-sectional area and mu is the permeability of the material. The unit of reluctance is ampere turns per Weber.